Hey, this is a video about how to figure out empirical formulas of compounds. So an empirical formula is the lowest ratio of the atoms in a compound. For example, like CH. It's not necessarily the true chemical formula, it's just the lowest ratio. So 1 mole of carbon for every 1 mole of hydrogen. The molecular formula is the actual true chemical formula of the molecule. So, for example, C6H6 could be the molecular formula, but its empirical formula would be CH. So here's a table that kind of shows you some examples. So sometimes, I'll just show you, they're just like this is the empirical would have to be multiplied by 2 to get to the molecular, this one by 2. But this one, they're the same. So sometimes the lowest ratio is the actual molecular formula. So we're going to do problems and we're going to use these steps. So I'll just read them to you and then we'll apply them. So if you're given percent composition of the elements in a compound, we're always going to assume that we have a 100-gram sample. So then what happens is those percents then become grams. Then we're going to use molar mass to convert those percentages that are now grams to moles. Then we'll have to divide by the smallest number of moles and hope for whole numbers, and if not, then we have to multiply by a common number. So let me show you one. Let me erase and we'll do it together. So for this problem, you can see that we have the percent composition of the elements in the compound. If you hadn't been given these, you would have to calculate them. So we're going to take the percent, and we're going to assume that we have a 100-gram sample. So 43.4 now would be that many grams of sodium. And we're going to convert that to moles. So 22.99 is the molar mass. And that's the mass of 1 mole of sodium. This cancels, and I end up with 1.888 moles of sodium. So similarly, I'll do the carbon. And 1 mole of carbon has a molar mass of 12.01. And then I'm going to get 0.9409 moles of carbon. So when I do these mole calculations, it's good to go out quite a ways, because you'll see when you try to divide that, you'll have better luck if you just take those out pretty far. So I am converting the oxygen now. And I'm going to get 2.831 moles of oxygen. So one thing sometimes I do is I show you, what does this really mean? It means that I have 1.888 moles of sodium, so my subscript would be that. And then I have 0.9409 moles of carbon, and I have 2.831 moles of oxygen. So this is silly. So what we're going to do is divide these all by the smallest number of moles, so the 9409. And when I do that, I'm going to get, sometimes not exactly, like it might be 1.999 or something, but this is going to be 2. This would be a 1, which we don't need to write. And this would be, when I divide those, I get about a 3. So once I do this, this is my answer. So right here, that would be my empirical formula. So what happens when those numbers, when we divide, like for example, let's say this was our calculation and we're going to get a 1, a 2.47, and a 1.5. These are not close enough to round. You wouldn't want to round that down to 2 or that up to 2. So what we do is we multiply all of these moles now, if we just double them, so multiply by 2, then we'll get whole numbers. So when I do that, I'm going to get 3 moles of carbon, sorry, 5 moles of hydrogen, and 2 moles of oxygen. So you will encounter that. And like I said, unless it's close to a whole number, it would be like, 3.0001 or something, or 2.999. Then when you get into these where they're halves, you're going to need to multiply all of those by 2 so that you can use whole numbers. So that's it.